So, yesterday we went over combining like terms, aka simplifying polynomials. More specifically, adding and subtracting polynomials. That's what we did yesterday, if you really think about it. We went over stuff like 2x plus 5x. Well, yeah, let's just look at it like that. 2x plus 5x, what did it equal?
7x.
It equals 7x. And if you notice, we were adding, or if we did this one, 7x or 2x minus 5x, what did it equal? This one was 7x. This one was negative 3x. If you notice, all we did yesterday was adding and subtracting, right? When you see polynomials, when you see expressions with terms, with variables, and it's telling you to add or subtract, the rule was you must first check whether they're like terms to see whether they could even be combined in the first place, right? If they're like terms, boom, the rule is throw over the matching variable that they all have in common, including its powers, right? And then just do the operation of the number. 2 plus 5, which equals 7. 2 minus 5, which equaled negative 3. All we were really worrying about was the number parts. The variables were being just all copied. Because they were like terms, they were just thrown into our final answer. There was no trick with the variable. That's what we did yesterday. Today, going over multiplying polynomials is different. Completely different set of rules, which if yesterday was easy for you, today's going to be easy also. But when does the complication come into play? Is when you are given questions that have both adding and subtracting and multiplying polynomials, and then you get your rules all mixed up with one another. That's going to happen to you, I promise. But just try to stay focused and separate the two distinct worlds of adding and subtracting versus multiplying, and you'll be good. So this is what we're going to do. We're going to look at an example of multiplying. Let's start with the simple one. 2x times 3x. What does that equal? If you had to guess, what was it? 6x. Beautiful, beautiful, beautiful guess. 2 times 3, because we're multiplying now, what does it equal? 6. Good. And just like yesterday, you saw that they had matching variables, so you just brought it over, right? That's a good guess. Yes. So the answer of 2x times 3x is actually 2x squared. Does anybody want to ask why?
How? Why? Never asked why.
In this specific case, you must ask why. And it's really important to ask why. And it's really important for me as an instructor to maintain my salary from the college to do my job and teach you why. So that's what we're going to do. We're going to go over the why. So here's the thing. In the adding world or subtraction world, we just did the operation 2 plus 3, which equaled 5, and then we just brought over the matching variable. In multiplying world, which is this one right here, we do not follow that same rule. The rule tells us, yes, multiply the numbers. Okay. The thing it also tells us is multiply your variables. X times x creates x squared. But how does that work? Why does it become x squared? Because, tell me, my friends, what do those x's have for its powers?
1. One?
Yeah, that invisible to the power of 1. Well, tell me, my friends, what's 1 plus 1?
2.
That's where you get your 2. So even though I say, and even though the question says, or the video, or the book, or whatever it is, even though it says, what is x times x? You are in reality adding the exponents of the variables. So that's a pretty straightforward one. Now let's look at one like this. Well, actually, let's stick with the same one, just a little different, just so you could get the concept down. 2x cubed times 3x to the power of 4. Tell me, my friends, what is the final answer? 6x to the power of what?
7x?
To the power of 7?
7.
X to the power of 7?
Yeah.
Okay, how come nobody here said, wait a minute, those are not like terms? So, the thing is, this is correct. You are correct. But majority of the times when I give this example, students say, you can't do anything. 2x cubed times 3x to the power of 4 cannot be done because they are not like terms. Got you, Neil. And I'm like, didn't I just tell you? This is a completely different world that we're in. We are multiplying polynomials here, you guys. They have its own different set of rules. And in multiplying polynomial world, you can multiply anything with one another. It does not have to be like terms. This could have literally been, well, I won't erase off of this one. I will just create the next problem that we could see the example of. Such as this, -2 z squared minus -z, oopsies, yeah, that's correct. Although it was a positive z. Three x 2 z. Let's look at that. My friends, this has just a z squared. This term over here has an x squared z. Those are not like terms, but like I said, when you're multiplying, you could multiply anything with one another. Now, how do you multiply this problem right here? I'll tell you how. You use the step-by-step method. It's a little thing I call the step-by-step method. What I mean is, if you're careful enough and you multiply little by little and you focus very detailed, each item or each individual item that's in each term, if you focus on it individually, you will be safe all the time. This is what I mean. Start with the numbers always. What is -2 times 3? -6. That's going to be a big one. Don't lose track of your negatives. And then that's your numbers done. Move on to the next item. In this case, the z, right? We're chugging away little by little. It's the step-by-step rule. So z squared times, is there a z on this side, on this term?
Yes.
So you go to that z. Now just ask yourself, what is z squared times z?
2.
It is, watch this, z to the power of 3. Do you see why? Z squared times z to the power of 1. Z to the power of 1. Well, tell me, what's 2 plus 1? It's my 3. That's why it becomes z to the power of 3. Now, move on to the next term. In this case, there isn't none, but there is a little loner here, right? This one has a z squared. Does it have a z squared here? Or does it have a, sorry, not a z, an x? Does it have an x on that side?
No.
No, those are the easy ones. Whenever you have one on one term, but not on the other ones, it's easy. That one just gets brought down exactly the way it is. So it's x squared.
Doesn't matter if it comes before this is answer.
What was that?
If you put it before z.
Haha, so, you guys jumped ahead. This is a correct answer. That's the correct answer. But like I said yesterday, math likes to rearrange stuff alphabetically, right? So the way your answer is going to look, and the way I should I just recommend you to start building this habit of writing final answers in standard notation. The way your answer is going to look under multiple choice options is negative 6x squared z cubed, alphabetically. X, Y, Z, am I right? X comes before Z. If you're wondering, but the Z has a power of 3, and the Z has a power of 2. Didn't you say that powers also matter in rearranging your stuff? It matters in terms of multiple terms. So if I had if I just happened to have another, which we're about to do next, so don't worry about that, but you could have more than one term, such as, I don't know, a 2x cubed z4, right? This one has to come before this one because of its powers being bigger than those ones, right? That's when you really focus on powers, if you have multiple terms that you have to rearrange. But when looking at one term individually, the variables are always going to be rearranged from alphabetical order. X, Y, Z, A, B, C, all this, all that. Again, do not let this whole ordering thing trip you up. It'll come naturally. You'll spot that your answer will match that answer, and you'll just make the conscious decision of knowing that it should be your answer. Let's do one more of these before we jump into the rest of the lesson. A squared b cubed c times b to the power 4 c. Alrighty. Step by step. Always start with the number. What are my numbers multiplied with each other? Well, I have a 5 here, right? This one doesn't have a number, but what is the number?
1.
If it helps, always put a 1 in front. So tell me, what's 5 times 1? 5. Okay. Number, check. You just got it. Now move on to the next term. Item, I should say. Oopsie. A squared. Tell me, does this term over here have an A? So what do we do with those? You bring it down exactly the way it is. Move on to your next item, your B. Is there a B on this side?
Yes.
There it is. All right, so now we have a B cubed over here and a B to the power of 4 on that side. B cubed times B to the power of 4 is what? B to the power of 7. Because even though I say, what is B cubed times B to the power of 4? it's your job to know that you're technically adding the exponents, not multiplying. Even though I say, even though the book says, even though the question says, what is b cubed times b to the power of 4? This is, even though that is multiplying, it's technically adding. You're adding the exponents. Adding the exponents of variables is how you multiply variables. It's a complicated loop. It's a complicated little trick. But you can get it. So, that was that. Now we move on to the next term, the next item, our C. Is there a C on this side? Yep. Tell me, what is C
1
times C?
2.
Z squared, Z to the power of 2. And just like that, this is your final answer. Does that make sense? After this lesson right here, you are probably going to get so confused that when I give you this, which is what we did yesterday, you'll probably, it's a common mistake, give me 5x squared, which is incorrect.
Incorrect?
That's incorrect. Look it, this was adding. Yesterday we did adding and subtracting. Yesterday we saw that in order to add or subtract polynomials, you just add the numbers, if they're like terms obviously, get your answer there, and then the matching variables that they both have in common, you just bring it down. Which means this does not need to be there. That's what we did yesterday. Look at your worksheets if you don't believe me. You probably already forgot it after what I just taught today, right? So, yesterday was simple, today is simple. It's when you start mixing the two by accident in which you get the wrong answer all the time. So, we do got to turn it up a notch though with our multiplying polynomials. We have to turn it up a notch. What I'm going to do is write this out. Negative 2z squared times z, right? But there's a little addition added into it. Plus 3yz. We're turning it up. We're turning up the heat now. So, what do we do here? Any guesses on what we should do first?
The numbers.
What is that? Parentheses. So, good. PEMDAS, right? Our minds always says, all right, we got to do anything that's inside parentheses first. Tell me, can we do what's inside the parentheses?
Yeah.
What would it be?
Put a 1 in front of the z.
That's fine. Put a 1 in front of the z.
And then there's another z in there too.
So, let me stop you there. This is an addition problem. What did we say yesterday? In order to add or subtract, it must be like terms. This 1z, this is a 1z there, but this is a 3yz. Those are not like terms, my friends. So guess what? You can't do what's inside the parentheses. You can't. And majority of the time when you're dealing with polynomials, you won't be able to do what's inside the parentheses. Which is why we resort to multiplying polynomials. What we end up doing is asking ourselves, okay, I can't do what's inside the parentheses first. But what I can do is multiply. Over here, there's a small little multiplication sign. Negative 2z squared times all of that. How do you do that though? we do something called distribution. This is what you're going to do. You're going to multiply this outside number to everything on the inside individually. We're going to break it all out of the parentheses so we could be left with a simplified polynomial. So this is what I mean. Let's do the first one. Negative 2z squared times z. What is negative 2z squared times z?
2 minus negative 2?
If it helps. If it helps. Rewrite your problem. Rewrite your problem as if it was the ones that we just did a second ago. A monomial times another monomial, as in one term times one term. If it helps, you could rewrite on the side somewhere negative 2z squared times z. If it helps you, do that. Tell me. Negative 2 times, what's the number that this z has?
1.
1. 1. So what's negative 2 times 1? Negative 2. Z squared times z. What's z squared times z?
3.
Z to the power of 3. So that's this first multiplication here, which is that answer right there. If it helps, you can, on the side somewhere, rewrite it as if it's its own little separate problem. Don't worry, it'll all come together at the end. Just follow along. So, now we come back to this original problem up here, and we multiply it with the outside one. And again, if it helps, rewrite it as a separate problem. By the way, this is a positive 3. This symbol in the middle is always attached with that number. So if it was a minus, you would put negative 3 there. But it's not, it's a positive, so it's a positive 3. So now we have our own little problem here. Let's solve it. Tell me. Use the step-by-step rule. It's going to help you always. What is negative 2 times 3?
1.
Negative 6, not negative 2 plus 3. Negative 2 times 3. All we're doing today is multiplying, right? Chug away. Z squared times z is what?
2.
Z
3.
to the power of 3. And then this little loner here, y, but there's no y over here. Guess what? Gets brought down. X, Y, Z. The alphabet tells us that it likes it in front, so if it helps, put it like that. If you did it the other way that I just had it, I personally would not count that against you, right? Yeah.
So why is the z got a 3 on it?
Because z squared times z to the power of 1, what's 2 plus 1?
Oh, okay.
To the power of 3. So, now what do you do, my friends? Literally, you're done. That's your final answer. These two answers, you just honestly, you don't combine them, you don't add or subtract, you don't do anything. You just literally put them together as your final answer. So just bring this one a little closer here. Right there. And boom, there's your final answer. This is called distribution. This is honestly multiplying the outside number that's attached to the parentheses to everything on the inside. This times that creates this. This times that creates that. Distribution. But again, even though you're doing a lot of multiplication and it might seem overwhelming, it's really just a whole bunch of these ones. You're just doing a lot of it. just like the first example we did. Any questions on distribution? It's always going to look like this, either this complicated or a little less complicated, such as 2x plus 3. Tell me, what is 2 times x? 2x. Again, step by step. 2 times, what's the number that the x has? 1. X times no x just gets brought down, so 2x. So now tell me, what is the same number on the outside, the 2, times positive 3? Times positive 6, and boom, there's your final answer. This is an example of a simple distribution problem.
If it is longer than let's say the first one, it's z plus 3yz, but it continues like 3 times.
Plus 6x something.
Plus,
Yeah. You continue on with your distribution. You just multiply out. Always the outside one gets distributed, multiplied to everything on the inside. Yeah. Now, I don't think we come across that here. But yes, for your own side note, if you were given something like this, there's nothing to combine on the inside. There's nothing to combine on the inside. So, yes, we do distribute out. Are you going to come across that here? No. Are you going to come across that later in the more advanced math? Yes. Well, what do? Distribute. So there's one more I have to do. A little bit more complicated. Yes, sir. Really? Nobody laughs at that? We're going to turn it up to 11. So, now I'm going to give you this right here. Yes, yes, this famous problem. This famous problem has a name to it. It's all multiplying. It's all multiplying. But the thing is, it's more of the little arrows and it's more of the little keeping track of what you have to multiply to what. But this one has a very unique name because that name is an acronym which stands for something. This right here, my friends, is the famous FOIL. Who here has heard of FOIL? So, FOIL stands for something. Let me put this to the side because we're going to do that one as a class. FOIL is an acronym to remember these types of problems. And it stands for first, outer, inner, oopsies, and last. So why is that an acronym? Why is it called FOIL? What does that have to do? Well, that's just an acronym used to help you to remember what you have to multiply to what. So this is what we're going to do. Make sure you write down that what FOIL means, because I'm about to hide it right now so I can make space. First, outer, inner, last. FOIL. So this is what we're going to do. We're going to follow that acronym and multiply our firsts together. What I mean by that is this is your first and this is your first. They're pretty much the first ones of each parentheses. And you are going to multiply those together. And again, if it helps you, on the side, you could rewrite it as if it's its own little problem. That's in essence all it is. 2x times x. It's literally just this. 2x times x. If seeing it like that helps you, do it all the time. It's not a big deal. Sure, you might use more paper or more time, it don't matter. But in essence, I'm asking you, what is 2x times x? Tell me what 2x times x is.
2x.
2x squared. Why? Because
Invisible.
there's a power of 1, a power of 1. What's 1 plus 1? 2. Okay, guess what, my friends? That's your firsts. Done. Now, what was the next thing on my acronym list? Outer. So guess what you do? You multiply this same first one, but now with the outer one. Now tell me, what is 2x times negative 5? And again, if it helps you to look at it like this, do it every single time. 2x times negative 5. What is that? Okay. 2 times negative 5 is what? Negative 10. X times, is there an x here? No, so it just gets brought down. Negative 10x, step by step. Always look at it step by step. Okay, that's my outers. Done, out of the way. Now comes everybody's favorite. The inner. Why is that everybody's favorite? It's because it's easy to remember. You just multiply your inners with each other. Your positive 3 times x. What is positive 3 times x? Positive 3 x. 3 times 1 is 3. Sorry, I should always say positive or negative. Positive 3 times positive 1 is positive 3. X times no x here just gets brought down, x. Now comes everybody's other favorite one, the last. Why is that everyone's favorite? It's just because it's your two last ones. Your 3 times negative 5. Tell me, what's positive 3 times negative 5? Negative 15. My friends, look at that. You just foiled 20,000 points. If somebody could tell me, is there anything else you can do here?
We convert that into money.
Huh?
Convert that into money.
I'll stick with little bonus points. Little measly, not count for anything points. So what was it?
You gotta work on the 10 and the 3.
Yeah, so yesterday's lesson creeps in with FOIL. It creeps into our FOIL problem because if you notice, we have two little like terms that want to be combined with one another. Tell me, what is negative 10x plus 3x?
7.
Negative 7x, is it squared? No. Good. Again, when you're combining like terms, you don't do those little tricks of adding the exponents and this and that. Don't let that confuse you. So, final answer, really, in reality, is, bring everything else down, 2x squared minus 7x minus 15. We just did FOIL. Majority of the times you will be able to combine like terms of the middle two terms. Majority of the times. Not all the time. I think in this worksheet, majority of them you can't combine. But for those of you taking your GED, for those of you taking any specific tests or moving on to advanced algebra, majority of the times you'll be given FOIL problems that look like this, in which majority of the times they want to see whether you remember to combine any like terms. Majority of times it's going to be in the middle. So, my friends, we just did all of this right here. Let me go over it one last time. Hopefully you wrote this problem down. If not, I'll come back to it in a sec. We started off with doing problems like this today. 2x times 3x. The fancy wording of this is a monomial times a monomial, which is just fancy lingo of saying one term times another one term, right? We then turned it up a notch and we did, distribution, which is a monomial times a binomial, which is just a fancy word of saying one term multiplied two terms in one parentheses. We distribute. Then we turned it up a notch even more, and we did FOIL. All of this is multiplying polynomials in a variety of different ways, but still using the same math. Number times number, variable times variable. Keep it in mind that you're really just adding the exponents of the variables. It's going to be extremely tricky and tedious, but guess what? Tomorrow you have a whole day to review it. Yes, that is right. For those of you that came in late, let me just end this, because that is pretty much the end unless anybody has any questions. Question.